Well, a database is necessary to identify how supplements affect various health metrics. This is important as the current supplement industry is projected to increase 9.1% from 2024 to 2023, and it's currently valued at 177.5 billion. So it's important because the relationships of how certain supplements such as caffeine or creatine affects an individual's athletic performance or their health can be misleading and often have consequences for an individual person consuming the product or the supplement companies marketing the product. For instance, for a company marketing the product that had a consequence, Monster sued Bang Energy Drink for $239 million in damages of false advertisement claims for claiming that super creatine would enhance mental performance, and there was a lack of data backing these claims, which allowed Monster to sue them. Furthermore, a supplement known as 1,3-dimethylamine was responsible for fatalities, which was later found to potentially increase blood pressure to fatal levels. And there was no back data with this either. So a database could have prevented both of these two consequences from occurring. So as the supplement and diet industry grows, a database is necessary to serve both the consumer and supplement companies. So as the supplement industry is increasing, we need to understand how these affects health, right? So a lot of these relationships between the properties and these supplements or chemicals and how they affect health can often be misleading, and there's not necessarily large amounts of data to support claims that a supplement might increase, like how much fat you're burning. So for instance, I propose a database that will have collected biometric data from users who are wearing a Fitbit device during their workout who have consumed a supplement. So we'll have collected biometric data from users who have consumed a supplement. And that and the Fitbit will read the biometric data in real time, and then MapReduce will be used to sort the incoming input as information into a NoSQL column database. So our intended result is to provide clarity within the diet and supplement industry to see how these supplements are impacting them. And this is going to provide research and data to companies and users looking to observe how these supplements are affecting health. So our methods of data collection. In step 1, we're going to be using PPG sensors on a Fitbit device to collect biometric data during a workout. Step 2, we're going to be using MapReduce to sort the incoming biometric data because there's going to be a high volume of biometric data that's being read. And in step 3, the output of MapReduce will be sent into the NoSQL column-wide database. So step 1, collecting data during a workout, we're going to need to collect this biometric data in real time, and we can do that by partnering with Fitbit. So Fitbit in 2023 registered 38.5 million users, and with a partnership with Fitbit, there will already be an established population to pull a sample from. So for the user wearing the Fitbit device to obtain their own health vitals, they will need to enter what supplement they consumed, and they will need to input their height, gender, and weight into the Fitbit device. And so the PPG sensors on a Fitbit device will collect the biometric data during a user's workout. And the PPG enables the Fitbit to track health vitals in real time, such as heart rate, HRV, blood pressure, through emitting light through a person's skin, which reads variations in blood vessels, and that output then collects biometric data. So our PPG can track our heart rate, our HRV, blood pressure, fat carbon oxidation rate, and other biometric data. But because we're going to be having a large amount of volume of data incoming from the Fitbit device, we're going to be using MapReduce to sort that biometric data. So it's a necessary component to obtain the biometric data from the device, and then the process will use the person ID as a factoring key, and a final output will include the person's ID, supplement type, biometric data, and a key value, and this output will then transmit the data into the database as it contains in order to see how these supplements are impacting various health metrics throughout a workout. So step 3, we're going to be implementing the use of a NoSQL column database. This database will need to scale horizontally for when new supplements are created and handle large volumes of data and able to effectively carry large amounts of data. For instance, this would be valuable for a company interested in the effects of caffeine on beats per minute for individuals within a height range. And users can also use this to obtain the same thing. So we can input to return all values with caffeine and beats per minute within a height range. And then with our database, we're going to be having row keys, and that contains the individual variables for that person. So for instance, we'll have one column family with biometric data, and then the other family will be identifying values such as their sex, age, height, and weight. So this is going to be useful because column databases are more suitable for this biometric data over key values. Document databases and graph databases. Key values can only carry a row key and often struggle when handling large scale data. Document databases are going to be more appropriate for handling large unstructured data. And graph databases, although can provide relationships, they can struggle with large volumes of data because there will be a high latency from all the connections forming between the nodes of the data being collected. So step 3, a snippet of the database codebook. We have a column family describing the user, so their height, age, sex, and gender, and then the column family describing the biometric data. So this will be our biometric data that's going to be collected by a Fitbit device, such as our heart rate, our HRV, fat carbon oxidation rates, and our blood pressure. So separate. We want to develop a Fitbit device using Cassandra to support availability and participation tolerance, enabling eventual consistency. So availability is important to ensure that the database can respond to user requests to observe if the supplements are safe, so it's always available then to pull out that information for users and companies or even researchers looking to access this data. And then this is important because they can easily see how these supplements are affecting various health vitals. And then this is also going to be important is because we want this database to scale horizontally, so we can update the database as new supplements are being introduced into the supplement and fitness industry that users will be inputting into the database. It's important too that we have partition tolerance because the database can function and be updated during a partition. Now, this will be necessary to function when the network is down by having multiple servers containing data replication. This database will be constantly updated with new incoming biometric data from the user's Fitbit device, so it will be necessary for this data to be always available and updatable through participation tolerance, even though the network is down. And in order to account for consistency, this database will use eventual consistency for collecting this data. So for this database structure, we're going to be using a distributed hybrid cloud system, and this enables for eventual consistency using master replication. So this will help the database handle large volumes of data with low latency using replication. So data can be sent into the database and replicated from the master node, and this will ensure participation tolerance in case the system were to shut down. And then since the servers will still be able to communicate with each other, and then once the network is back up, this data can be updated to the master node and replicated among all slave nodes. So this cloud database also will ensure a cost-effective method of ensuring that the data can scale based on the operational requirements, basically how much traffic is being used in the database, and it can scale the computing operational power based on the incoming amounts of traffic. And then using platform as a service, this third party will be useful as it can update the uptime and status on their own, and the information of the person's ID will be kept in-house. So our anticipated results, this database is going to provide biometric data to the Fitbit user base, supplement company, and researchers. Now, essentially, this provides biometric data for the user, provides a database with supplements effects. So this is going to be important for the user because they can evaluate how the supplements are affecting their own health, and then the user base can access the database to observe how other supplements are affecting those like them and gender, age, weight, and height to observe the supplement is safe, and they can also evaluate how in real time how the supplement is affecting them during the workout. This will transform the availability and clarity on supplement effects for the fitness industry. Researchers can also use this database for their own individual research, as projects can often be not funded, and data can be hard to come by, and often these research projects can be expensive. So, but for supplement companies, this will provide marketable data. So for instance, if there's data saying that a supplement actually does increase how much fat is being burnt in a safe way, they can use that to market their product. Furthermore, they can also identify which are the most popular supplements within the database by using a query search, such as like if taurine is being used more commonly, they can observe that in the database and use that in their products and market that as well. And this also provides them with a safety net for their data, as they can use it to support their claims to prevent potential lawsuits from occurring, and also prevent their consumers from experiencing any negative effects that a supplement might have on them. So our alternative methods, we could have used a graph database using the O4J to find relationships. However, these often struggle to scale horizontally, as we want to add more supplements into the database as they're being developed and the industry grows. Furthermore, in case Fitbit device, they don't want to cooperate, there's other Fitbit devices companies to work for. So the Fitbit device market was valued at 53.94 billion in 2023, and there's a lot of competition within the fitness watch industry. So we can provide marketable innovation for companies looking to fit out from the rest of them, and some companies would be Amazon, Nike, Apple, or Samsung. The supplement industry grows to increase from 9.1% from 2024 to 2030. The relationships of how certain supplements such as caffeine or creatine, how they affect an individual's health vitals need to be understood and backed by data. So we really need the supplements' effect on health vitals. They need to be understood and backed by biometric data. So what we're going to do is we're going to provide a database with high volumes of biometric data to serve the user, research, and supplement companies. And this is going to provide inexpensive biometric data, so no need for additional experiments, as it will be updated in time by users using their Fitbit devices. And it's going to provide new marketable features in a competitive growing sports watch industry. And this is going to be really important to provide clarity on how supplements affect individuals in fitness and industry. Thank you.